All right, welcome back everybody with circuits. We are finally talking a little bit about power, electrical power when it comes to electricity. All right, here we go. So power, which we learned about in the unit of energy and work, is the rate that energy is used or work is done over a period of time. So how much energy is used during a certain amount of time. So a lot of energy is used in a short amount of time. That means a lot of power was exerted. Things you could think about: if you sprint really fast, you're using up a lot of energy. You're doing a lot of work in a short amount of time. Okay. As electrons run through a circuit, it provides energy and does work. Light up a bulb, heat up a room, cool down a room, etc. This energy it provides in a given time is power. So power is equal to the current of electrons times the voltage. Okay. And here we have the formula here. This is the main formula. And here is how you can change it algebraically, manipulate it algebraically to find other variables. All right, moving on. Good video about this. All right, so some simple examples we're going to do here. Calculate the power consumption of a light bulb that draws a current of 0.75 amps when connected to a 100 volt power supply. So power is equal to current times voltage. In this case, we don't really have to do much. Anyway, solve it for yourself if you know how, and then pause it and everything like that. So 0.75, voltage 100, and this is going to be 75 watts. What? All right, there we go. Moving on. A current of 3 amps flows through a 5 ohm resistor. A, what is the voltage across the resistor? B, how much power is dissipated by the resistor? All right, so A, we're going to have to use Ohm's law. V equals IR, and we're looking for voltage. So I is 3, R is 5. The voltage is going to be 15 volts. Okay, that's A. Now that we have volts, we can find how much power is done. How much power is dissipated by the resistor. Power is equal to current times voltage. Current is 3, voltage is 15. Power is going to be 45 watts. All right, moving on. Conceptual example 6. Which of the following changes would increase the power output of a resistor? So remember, let's look at the formula when trying to solve stuff like this. Power is equal to current times voltage. Decreasing the voltage. No, if this went down, this would probably also go down if the current doesn't change. Increasing the current. That looks promising. Adding more resistance. No. Removing the power source. No. So yep, it's going to be increasing the current. If this current goes up, that means power is also going to be going up. All right, moving on. Why does a higher wattage light bulb produce more light? I don't know if you guys have ever dealt with light bulbs, but they come in different wattages, like 60 watts, 30 watts, so on. A, it has higher resistance. B, it allows more current to flow through it. C, it has lower voltage rating. D, it generates less heat. So remember, power is equal to current times voltage. More power is going to mean there's going to have more current allowing to go through it. Okay. Moving on. What does a watt rating on an appliance tell you? The resistance of the device. B, the maximum voltage the device can handle. C, the rate at which the appliance uses energy. D, the amount of current required for operation. So remember, the watt is a form of power, and power is all about energy, how much energy you use over a period of time. So it's going to be the rate at which the appliance uses energy. That's what the definition of power is, how much energy something uses in a given period of time. All right, moving on. A 10 ohm resistor has a current of 2 amps flowing through it. What is the voltage across the resistor? How much power is dissipated by the resistor? Okay, similar to one we've done before. We're going to be using Ohm's law. Voltage equal to current times resistance. Current is 2, resistance is 10, means the voltage is 20 volts. Now that we know that, we can solve for power. How much power is dissipated by the resistor? power equals current times voltage. Current is 2, voltage is 20, and we got 40 watts. Alright, moving on. A 9-volt battery powers a small motor that draws 3 watts of power. What is the current through the motor? Okay, so A power is equal to current times, voltage, not W, voltage. We are looking for current, so let's manipulate this formula. Current is equal to power divided by voltage. Now let's plug some things in. There's 3 watts of power. The voltage is 9. So now we can see that the current is 0.33 amps. Okay, or 1/3. Same thing. What is the resistance of the motor? So now we know the current. We can use Ohm's law to find this. Ohm's law, V equals IR. We're looking for resistance, so let's do some manipulation. Resistance equal to V divided by I. V is 9, current is 0.33. Let me put this into my calculator. It is 27.27 ohms. Alright, moving on. Oh, not moving on, that is it. Alright, thanks for watching, everyone. I hope that all made sense, helped you out with power. Next time we're doing a bigger subtopic, which is resistors in series. Not too difficult. I think you guys will be okay with that, but I'll see you with that. Thanks for watching, everyone. Bye.